Hello everyone in CIS-115. This lecture is on for loops. You can find the exact textual material that we're using in this lecture if you click into course content of CIS-115 and then go to module 4. And the material is right here, for loops, lecture, and activity. Now, the whole point of these textual lectures is you're supposed to try this code. So that's what I'm doing in this video, and you have got this code exactly in Blackboard. So I'm going to take this code and copy it to the clipboard. I just drug across it, right-clicked, and said copy. And I am going to go into a Tawny window. I've already created an empty Python file named test for loop. I'm going to paste this code in. And what you're going to see when it runs is exactly what it shows you there in Blackboard. When I run it, you can see it starts a for loop at 0 and runs up to 9. So what that did is this looped, these two lines of code right here looped over and over. It started at 0 and it ran up to 1 less than 10. 1 less than 10. So each time through the loop, this variable I, which is our loop variable, gets bumped to the next item in the range. So it starts at 0 and runs through 9. It might be helpful to look at what this range 10 does with this for loop. Now, a little background on for loops. We use for loops anytime that something needs to be done a specific number of times. That's a finite number of times. If we know in advance how many times something should be done, or we know it's going to be done a specific number of times and stop, then a for loop is a good choice for that. In this case, we knew that we needed to print I exactly 10 times. You can see that we started at 0 and we ran up to 9. So before we go on, let's talk about what this range statement actually does. It may help you understand for loops a little bit more. So what the range statement does is it produces a list of numbers, and we can see that by doing this: print list. Okay, so what I have done is I have an outer print. Okay, that's a closing parenthesis for the outer print. There's our print. There's a closing parenthesis. Inside the print, I have a list function. This changes things into a list. And then here I'm going to put range 10. Okay? So here's my range statement that we were using in that for loop. And here I'm changing it into a list, and here I'm printing it. So let's see what this produces when I run it. Do you see the list, the Python list that got produced? It starts at 0 and it runs up to 9. So this range state, I'm going to comment this out by putting a pound in front of it. I'm going to go back over here and I'm going to get this code again and put it back into Tawny so that you can see what's happening again. Now here's what the range statement produces, and here's what our for loop does as it iterates through each of these items in the range. So that's what that range 10 is producing, is right here. Our for loop says, I want you to bump I to the next item in this list each time through the loop. So that's a simple for loop. Now let's go down and look. Here's where it's talking about exactly what I just did with the print range. Okay. Now we can modify this range a little bit so that we can see what happens with the basically there are three versions of this range statement. Okay, so right now, where did this for loop that we had start? It started at 0. We can change that by putting a 1 and a comma inside the range statement. So watch how that changes what happened with the for loop. Where did it start now? It started at 1. It still stopped at 1 less than 10. So if we wanted to print the numbers 1 through 10, I would actually need to make my range statement this. Start at 1 and stop at 1 before 11. So let's run that and see what happens. See, it started at 1, it stopped at 10. So that's the second form of our range statement. The third form, and you notice I started out with just one thing inside the parentheses. The next step up is to tell it where to start and where to stop. And the last version of it is to tell it how much to step by each time. So if I wanted to get the odd numbers between 1 and 11, between 1 and 10, because it's going to stop at 1 before 11, I could do this. This says start at 1, step by 2 each time through, and stop before we get to 11. So let's see what that does, putting the step inside the for loop. What did I get? I got 1, 3, 5, 7, 9. So that's giving me odd numbers. How is it giving me odd numbers? We said start with 1. It did. It started with 1. The next time through, it bumped 1 by, it added 2 to 1, and we got 3, and that's what printed. The next time through, it added 2 to 3, and we got 5. The next time through, it added 2 to 5, and we got 7. And the last time, it added 2 to 7, and we got 9. Now, why did it stop at 9? Because once we add 2 to 9, we have 11. And if you recall, this says stop at 1 before this number. So it couldn't print 11. It had to stop. So that's the three forms of the range statement. Now, just to be clear, we can count down. We don't have to just count up, okay? And it doesn't care whether we put some spaces in here to make this more readable, okay? This said, what we have right now, again, said start at 1, stop at 1 before 11, and jump by 2 each time. Okay, so if we wanted to count down, we'd have to make our starting number bigger than the ending number. So let's say we start at 10. Okay, I want to stop at 1 before this number. So how about I say -1? that's where I want to stop it. What's 1 before minus 1? 0, right? So, and here for my step, I'm going to say increment by a minus 1 each time through the loop. So let's see if we can figure out in our head what's going to print for this for loop. It's going to start at 10. The first time through, it's going to print 10. Second time through, remember, it subtracts 1, so it's going to print 9. It should print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And it should print the 0 because it's going to stop at 1 before a minus 1. So let's try it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So again, that's a for loop to count down. And remember, it stops at 1 before this number. So that's what we just did right here with the counting down. Okay. This example shows that we can count by 5s. Let's pop this into Tawny. The idea again is that you would paste this stuff in and run it. Let me clear this out. Okay. All right. So let's see if we can figure out in our head what this range and loop is going to do. Start at 5, stop at 1 before 50, 1, and step or bump it by 5 each time through the loop. So we should get 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And it's going to stop at 50 because we said stop at 1 before 51. And there's exactly what it did right there. So that's where we stop in the for loops lecture. Now, let's look at a couple of the code lab items that have to do with for loops. So I'm going to pop into Code Lab. I can go straight to Code Lab with that link right there. And log in. And let's go to your class, the online class here. Okay, so let's pop into Module 4 and loops and for loops and ranges. Right here are our for loops items. Okay, so let's do the first one, 51,176. It says use two variables, k and total, and write a for loop to compute the sum of the squares of the first 50 counting numbers. Okay, so this is saying that we need to use what's called the accumulate pattern. Now, the accumulate pattern works like this. Let's go into Tawny again. The accumulate pattern says outside of the loop, we have to have a variable total in this case, and we have to make it 0 outside of the loop. Okay. Now, it says that you use two variables, k and total. Okay. So I just created my total. Okay. Now k is going to be our loop variable. Remember where we were using I with the previous examples? There's nothing etched in stone that says we have to use I. We can use k. So what would our for loop look like? Let's just see if we can write a for loop to roll through the first 50 numbers. It says counting numbers, so counting numbers are like 1, 2, 3, 4, 5, and so on. So let's do it. For k, I'm getting k from right here. for k in range. What does our range statement need to look like? If we wanted to go up to 50, which is where we need to stop, our range statement would need to say 51 because it stops at 1 before 51. So, okay, now let's just check our work right now. Let's print K. This is not the total answer in CodeLab, but I'm trying to demonstrate to you that this is going to print 1 through 50. Where did our loop start? 0. So it says the first 50 counting numbers. So I need to actually start my loop where? At 1. So we need to go back and change our for loop to say range 1, 51, because 0 is not one of the numbers that they ask us to use, is it? So now let's try it again. Started at 1, stopped at 50. Okay, this looks right. So now we need to calculate the sum of the squares of the first 50 counting numbers. So using our accumulator pattern, we set the variable equal to 0 outside of the loop, and then each time through the loop we add whatever we're calculating to it. That's the accumulate pattern. So the sum of the squares, to get the sum we would say total equals total plus, and what is the square? The square would be k times k, right? 1 times 1 and add that to the total, loop back up. 2 times 2, add that to the total. So we really don't need these parentheses around it, because if you remember, the order of precedence is PEMDAS, parentheses, exponents, multiplication, and then addition. So we really don't need the parentheses around k times k. So this should get us the sum of the squares, okay? Now, the sum of those squares, they don't ask us to print it, but in case you are curious as to what that would be, we could print it out after our loop ends. It's probably going to be a pretty big number, wouldn't you think? So let's run it. It's 42,925 is what total has in it when this finishes. So what do we need in CodeLab to satisfy CodeLab? We need this much. So let's try it. I wrote this code in Tawny and I tested it out. Okay. Now I'm going to paste it into into CodeLab and hit submit, and you'll see that it's happy with that. So that's what it takes to do these kinds of CodeLab items. Let's do one more here. 51,269. Okay, it says we're given a positive integer n, assigned true if it's prime, and that's it. Okay, so we need to write a for loop to figure out if this variable n has a prime number in it or not. So a number is prime if it has no factors other than 1 in itself. So we really need to start with, we know 1 is going to go into it. So we need to start at 2 and go up to 1 before that number. So, and try everything to see if it goes evenly into that number. So let's try working with this. Okay. First off, in order to test this in Tawny, we need to dummy up this variable n that they say has already been given to us. I'm trying to make an actual program that runs, so I'm going to dummy up n with a value, and so I'm going to do n equals, let's just say 10. Okay, now 10 is not a prime number because 2 times 5 will get us 10, so it shouldn't be a prime number. Okay, so the other variable that they said to use is prime, so I'm gonna set is prime equals true. Okay, and then if I find something that goes into this with a remainder of 0, then we know that this is not a prime number, and I'll mark it as false. So here's my for loop. We said we needed to start where? We needed to start at 2. So we can use I in range 2, comma. Where did we want to stop? We wanted to stop at 1 before n, 1 before the number, so n. Okay, so this is going to start at 2, it's going to stop at 1 before n, which is perfect. So here's our if statement. If n, how can we get the remainder? Remember modulo? N modulo I equals 0. What does that if statement say right there? If whatever number we're on right now in I goes into n evenly, then we have not a prime number. So I'm going to say is prime equals false. Okay, so this is saying if this goes into, if I goes into n with a remainder of 0, then we have found something that goes into that number, a factor of that number, and we need to mark it as not being prime. Okay, so one further thing that we can do here, if we've found something that goes into it, do we need to check any further? We know it's already not prime, if not a prime number, if we found something that goes into it evenly, so we could actually just break. This is a way we can exit out of a loop, the break. So that's going to jump out of the loop right now. We don't need to check anything else. So now that I've done that, okay, I'm going to, just so we can see what is prime has in it, I'm going to print it here. Now I won't put this into Code Lab. This does not go into Code Lab. Code Lab. And this doesn't go into Code Lab either. Okay, so let's see if this code works. What does it say when I run it? It's false. Now let's give ourselves a prime number. Will anything go into 5 evenly? What do you think? Can you think of anything that goes into 5 evenly? Well, I can't. See what it prints? True. How about what's another prime number? Is 3 a prime number? Yeah, I think so. There's nothing that goes into 3 evenly except for 1 and 3. So let's try 7. You can see this is working every time. So I'm going to take this code that we just wrote, copy it, and I'm going to paste it in. Now you notice I left some stuff out, didn't I? I left the initializing of n out, and I left the print statement out. So, and you can see CodeLab is happy with that. So, that's the for loop lecture. We'll talk about some other things in a separate lecture. The main things that I want to cover in that lecture are these various search patterns that are talked about right here, and the counting pattern, the accumulate pattern, the filter to accumulate, the search, the extreme. So we'll do another video to talk about how these patterns work. Okay? And good luck.